Okay, this is A2Pure notes. We're in Unit 5 and we're looking at functions. I've been through a lot of the basics of functions and a few examples, and now we're looking at composite functions. So consider the two functions. F of x is 2x plus 5 and g of x is x minus 3, where the domain of f is 1, 2, 3, 4, and the domain of g is going to be the same then as the range of f. This can be illustrated using a mapping diagram shown below. So if we sub in the number 1 into 2x plus 5, we're going to get 7. Sub the number 2 in, we're going to get 9. Sub the number 3 in, we're going to get 11. Sub the number 4 in, we're going to get 13. If we then sub this into our g of x function, so this one here is our f of x, and this has been sent through 2x plus 5, and then our g of x is going to be here, which then is x minus 3, so I get to take away 3 from each of these. So take away 3 from this, that obviously gives me 4, 6, 8, and 10. So here's really what it's saying. So the domain of f is 1, 2, 3, 4, and the domain of g is the range of f. So do you see here, if we cut this off here, here's the domain of g, and this is obviously in the range of f, so it's just the same thing. If we look down below, I guess we can kind of define our composite function. So sometimes it's written down as g o f or g of f. This seems the wrong way around. We'll explain a little bit more about this, but this is the domain of g of f, and that takes us all the way from here to here. So if I write here that this is the composite function, as in I've joined these two functions together, and then here will be of course then the range of g of f. The function indicated in the diagram with domain 1, 2, 3, 4 and range 4, 6, 8, 10 is called the composite function. The function is denoted by gf or gof. A single rule for the composite function g of f of x can be obtained in terms of x. Notice that f is nearest the variable x, since f is the first function to operate on the set 1, 2, 3. It's nearly looking the wrong way around. We've done f and then g, but you actually write it g of f. It's because whenever it comes down here, if we think about it, what do? We put the x through the f function first and then the g function. That's why it's written this way around. The rule for the composite function then is given by, so we're going to go for g of f of x. So we want to do, let's move this up so you can see it, g of 2x plus 5. So what does that mean? I substitute in 2x plus 5 into my g function, which is x minus 3. So it'll be 2x plus 5. I've changed my x into g of x for 2x plus 5. Take away 3. So my function then g f of x is then 2x plus 2. So 2x plus 2 is of course a function which will take you from here straight to here without going through the middle bit. Then, alright, the composite function g of f is defined by g of f of x equals 2x plus 2 with, so bad at this, aren't I? Where people can see, so the composite function gf is defined by g of f of x equal to 2x plus 2 with domain 1, 2, 3, 4 and range 4, 6, 8, 10. And hopefully again that makes sense. If the function g were to operate first on the set 1, 2, 3, 4, then f were to operate on the range of g, the mapping then would become what? So if we did it the other way around, say we did g of x, which is of course then x minus 3, x minus 3, that should give us then minus 2, minus 1, 0 and 1, and then we do our f of x which is going to be 2x plus 5. So subbing in 2x plus 5 into here, we get 1. We would get 3. We get 5. And we would get 7. So again, if we take this way around, this would be the composite function f of g. This is our domain of f g, and this then would be our range of f of g. And as you can see, these numbers 1, 3, 5, 7 are different from our 4, 6, 8, 10, so it is of course a different function. In this case, our composite function has a domain, same domain, obviously we're starting with the same numbers, 1, 2, 3, 4, and my range in this case is here, 1, 3, 5, 7, and then the rule for this function. So f of g of x, how would we work that out? F of g of x is going to be f of x minus 3. So anytime I see an x in my f function, I exchange it for an x minus 3, so it'll be 2 upon x minus 3 plus 5. That would give me 2x minus 6 plus 5, so my f of g of x is then 2x minus 1. So just a final wee statement then at the end, so you can see that okay. Right across here, the composite function fg is defined by, where are we, fgx is 2x minus 1 with domain 1, 2, 3, 4 and range 1, 3, 5, 7.